moving on. We are now at table 15.5. I may be going a bit quickly. Again, a lot of these are very factual, so you just need to read them and highlight what you don't understand and ask me. All right, I will not be going through them in class. All right, so I'll try as much as I can to explain. But remember, the quiz that I'm going to give you is based on this paper as well as the other slides. So table 15.4 talks about three systems for classification of mutant alleles. Again, if you have a mutation and then you know the mutation is causing an effect, so what does it? How do you classify it? So one is either loss of function and then or gain of function. That normally loss or gain is compared to the wild type. If you have more proteins or more function, then it's gain of function. If you have less or diminish or abolish, then it's loss. If the product is less active, right, it's loss of function. So, and then you're talking about dominance relationship, whether it's dominant or recessive, and then also this Muller's classification where you have this amorphic. Morph is type, so amorph, there's the type doesn't have any activity. Hypomorph, that means a type that has lower activity. Hypermorph, it has higher activity. Antimorph, that means it has an opposite activity. And neomorph, it has a new activity. So these are some terms that that you may want to have a look at. The next section, again, it talks about, okay, why have I highlighted this? So these are again referring to the terms forward mutation. You don't normally see these terms being used, but it's good for you to know. So this one talks about loss of function effects. Okay, mutations affect gene function in three ways. It may reduce or abolish activity, so they call it loss of function. It may increase or confer novel function, so you call it a gain of function. And then, but of course, you have some that doesn't do anything. You have a mutation, but it doesn't do anything. You have a phenotypically, well, it's either you see the phenotype or not, and these are called isoalleles. Now, why have I highlighted mutations? Mutations which cause loss or gain of gene functions may be neutral, beneficial or deleterious. So again, what I mentioned just now, you classify mutations, either they have a change in the protein structure. Having a change of protein structure again can be classified into three different categories, whether it's bad, good, or nothing, or does nothing. So it says mutations which cause loss or gain of gene function may be neutral, beneficial, or deleterious. It is important to distinguish consequence of losing or gaining the function of one particular gene. You want to remember that, from the consequence of losing or gaining overall fitness. Right? So that's why I say about fitness. Whether do you have any? Does it have any effect on your overall being? So this is the example. Loss of function at one locus results in totally harmless inability to roll the tongue. Right? So too bad you cannot roll your tongue anymore, but it doesn't have any effect in your overall fitness. Whereas a gain of function in an oncogene, well, of course, just a small word of explanation. Oncogenes are genes that causes cancer, but they're not there. You don't have oncogenes specifically because they cause cancer. Oncogenes are normal genes. Normally they call them proto-oncogenes, and these are genes normally involved in cell cycle, cell proliferation. It's just that when they become unregulated, when you lose control over these oncogenes, that causes cancer. So please don't think that genes are there just for the sake of, because some people say, oh, these oncogenes are cancer genes. They're not there to cause cancer. They are normal genes, but the failure to regulate that gene results in cancer. All right. Okay. other terms, down promoter mutations, either you total loss or you lose partially. Yeah, so you have down promoter mutations or loss of function. You have null alleles, total loss. You have leaky alleles, and also called hypermorphs. So these are again referring to terms. And you have haploinsufficiency, half is not enough. Antimorphs, again, that's why I said earlier, you know, if you focus on the tables, sometimes, you know, a lot of these are just explanation, but the tables are the facts that you may start at the tables to see what are the points that you need to give attention to. All right, I've lost time, so I'll continue in the next slide. See you later.